Hi team, good morning. Hi Shruti. Hi Mahendra. We'll start session in 2 minutes.
Hi, good morning, everyone. So, yeah, hope I can see the audience. And today we are going to discuss about the history of the DevOps and the fundamentals. So we'll go into the fundamentals of the DevOps. And so, what is DevOps? First of all, what do you mean by DevOps? Anyone in the call? So, what do you understand by DevOps? You can unmute yourself and you can answer the question. Anil, Mahinder, anyone, Shruti.
Uh, like if you want to deliver, sorry, if you want to deliver the product within short amount of time, you need certain tools. Uh, so those are, I think that is DevOps according to me. Like you need certain tools for the delivery and for the zero downtime of the product. So
Yes.
you need certain tools, and those are the DevOps tools. You use these DevOps to achieve those goals.
Exactly. It's a kind of process what we follow. And that process can be achieved by using these tools, right? So imagine you ordered food on Swiggy or Zomato and it says delivered, but you haven't received it yet, right? So what do? Then you call the support. They say, oh, the restaurant team says it's ready. The delivery team says it's lost, right? That you correlate those things with the developer. So software development cycle. Like for example, developer say developer says that my code will work, and operation says that application has been crashed because of your code. I mean, server has been crashed because of your code, and both will have quarrel, right? So who should blame here? either DevOps, either the developer or the ops, right? Who should play? So to combine those developers and operations is called the DevOps, right? So the core idea is to bring the teams together to run the show smoothly. So that's what the DevOps is. For example, if you see the the waterfall methodology, and a couple of years back, like decade back, the waterfall methodology, what the waterfall methodology will happen. So it's a kind of people, the developers used to bring the requirements and gather the requirements, and once they gather the requirements, they work on the requirements like developing or something, and they will give to the QA, and the QA will do the testing, and then they will give it to the operations, and operations will do the deployment. And for example, in the deployments, it used to take like 6 months and even more than 6 months to release to release one feature into the production. So that is how. Now after the DevOps, if you see, it will take within fraction of seconds. If you see the DevOps, or if you see the Netflix or Amazon, and you see the orders in the Amazon or Flipkart. So these all in the backend, it's happening because of the DevOps. And for example, in the waterfall method, in the legacy method, what happens like when, for example, after going to the production, it will fail. So once it fails, there will be no visibility for the developers or the operations. So they doesn't know what to do. And again, they roll back to the previous version. And again, they will start from the starting. Again, they will do from the scratch what happened and all. Again, they will follow the same process, kind of uh, deploying, QA testing and doing the deployment, handing out to the operations team, and the operations team will deploy the code. So these all things are happening. And for example, I'll tell you one thing. So couple of years back, the decade back, if you see, there are Linux admins. The positions in the industry are Linux admin and database admin. And if you heard, there are NOCs, NOCs, they will call NOCs, and network operation centers. They are called. There are NOCs, and there are multiple positions, right? So if you see now, the Linux admin or database admin, backup admin. So these all positions had been extincted, and they had renamed it as under umbrella called DevOps, cloud engineer, support engineer, and these all comes under DevOps, right? So if you see the opportunities also, if you see the opportunities list also, how many has been aggregated? So how many positions has been aggregated under the umbrella of the DevOps? You imagine. And if you, for example, the database admin, Oracle administrator, even the database administrator also, they are hiring under the DevOps, stating that if you know the minimum, and this database, what happened is, now if we move into the cloud, there are certain databases you just know it. Not only databases, like if you go to the servers, EC2 instances, or if you go to the network administrators. So within just a click, within just a one click, so everything is getting enabled, and you can able to see in the CloudWatch or analytics. So analytics log, Azure Analytics. So within just one click, you are able to see all the, I mean, uh, you're able to execute the, what do we call? You're able to execute, and you're able to see the logs, and so that is how, no, that is of the beauty, and you don't require from the scratch. You don't require the building of from the scratch, and the end to end, you should know that expectation has been gone. So what is the expectation is you have to know the Oracle. What is the Oracle? It means, I mean, database, what it does, the functionality. So if you know those things and how it works, if you know those things, that's more than enough. So, and if you try to uh, log into the AWS server, and if you deploy databases, for example, if you say MySQL or Aurora, and so there are some of the database services. So if you play with those database services, that's more than enough. And yeah, so that's what the DevOps was. And imagine, so for example, Netflix in the 2000s, or so they had physical DVDs, right? So I think most of the people had played with the DVDs, and you need used to store the DVDs, right? And so now, how many people are using DVDs, right? No one. DVD, I mean CD drive or any such kind of devices. No one is using. When they shifted online, every update took weeks to deploy for the Netflix, right? One small bug could bring down the site for hours, and fixing it meant, I mean, for multiple teams to coordinate. I mean, there are multiple teams to join the call, and once the site was down, and now what's happening? Now in the present scenario, the SREs are going to join the call, and there is a complete visibility from the end to end what's happening, where the system went down, and for example, if the system went down with the, for example, if the system went down with the uh, there is a bug called application, and immediately if there is a development, there is a if there is an development code error, immediately 500 or 404, if those kind of errors, easily they are able to troubleshoot it based on the errors. So the complete transition you are able to see, right? So what I mean, from the slow software releases to fast software releases, and there is a lack of communication to transparent between the development, QA, and operations, and from the frequent failures during deployment to, I mean, there is zero downtime, and doing the deployments with a high accuracy, and without failure rates, they are doing it, and so whatnot. Everything, the game has been completely changed, right? Now, as you know, the software, I mean, SDLC they are using is SL. So it's very small. The gathering the requirements and all, it became fast iterative releases instead of using long ones. So you can see the how the game has been shifted from the conventional to from conventional or legacy, we can call traditional, we can call from to the latest methodologies, the DevOps, right? So the first, I think, the DevOps came into the picture when it is on 2007 to 2009. So it's a kind of, I think Patrick was the one who was working on the data center migration. So he noticed that constant fighting with the developers and operations, and then he came up with the DevOps concept. So the world, I mean, that's where the word DevOps has been first officially born. So it's a kind of, as we know, the breaking the wall between development and operations. And Amazon is the first one to adopt it. So it is the first one, we can say early adopter. So they moved from deploying once for every few months to deploying every 11 seconds. You see, for example, if you order, how fast everything is happening. It is getting selected. It is getting whatever you selected. It is getting packed. It is getting shipped, and it is getting delivered. So these all things were happening within a fraction of, if you see Jepto, or if you see Swiggy, Blinkit, so all these things. And so this is what the DevOps and the history of DevOps and how it got transformed. And yeah, and any doubts here, right? So as we know, the main objectives of the DevOps are so collaboration, automation, and fast delivery and the reliability. And the collaboration is nothing but the collaboration between, yeah, the collaboration between the developers and operations. And the automation is something which we use the tools to automate. For example, you take Jenkins, and that is what we use commonly. And we got multiple tools like GitHub Actions, and we had GitLab CI/CD. I mean GitLab CI/CD and GitHub Actions, and so these are some of the tools which we use for building the code and deploying them onto the production, or deploying them onto the staging. And once onto the staging, it is done from the staging to production. So I'll tell you one basic scenario how we use in one of my experience. I'll tell you one CI/CD flow, okay, end-to-end CI/CD flow. So first, what developers will write the code, right? And what they do, they push the code in the Git. I'll tell you with the tools itself, you can correlate them. So with this, you can correlate how to start your DevOps course. That is also with this you can do that. So first, what you have to learn is Git or GitHub. What I mean, you write the code in the local, you push the code to the central repository, that is GitHub. When you push it to the GitHub central repository, usually in the environment, they will be having some, we will be having some mechanism to check before pushing it to the code to the repository. Before pushing it to the main repository, there are branches. For example, you say main branch is main is the one which is the, which is the main branch, or you can say master branch. And under the main or master, so I'm not writing any, sorry, I'm not sharing anything as of now. So I'll share once, once we get into the deeper, I'll you the, share you the screen, and I'll explain all the things with the PPTs or with the notepads. So I can, so once developer push the code into the GitHub, there are some validations checked before merging into the master or main branch. So that is checking the lint errors, and checking the checking the any code errors. For example, minimum code errors can be done by now enabling the GitHub Copilot, right? Even in every industry, they have done that, enabling the GitHub Copilot to check the code errors and lint errors. So there are some of the tools. First, they will check all those errors and the sneak. So for any vulnerabilities, if they had any, what do we call, if they had any exposed kind of secrets. So those are kind of the vulnerability scan will be done before merging into the master or main branch. Okay, so everyone has to create a PR, pull request. And once they create the pull request, it will be reviewed again. Once the all the satisfactions, once the all the requirements has been satisfied, it will be reviewed by your peer, by your teammates or by your team lead. And once he got satisfied, he will merge the PR, And once he merges the PR, it will go to main branch. From the main branch, it will, I mean, for every 1 week or for every 2 weeks, the pipeline will run. And once the pipeline gets executed, it will it will be built in Jenkins or backend GitHub Actions or GitLab CI/CD, and it will build the image and it will build the Docker image or it will build the artifacts and it will push it to JFrog or SonarQube repository. SonarQube. So SonarQube or JFrog, we use those are repositories, artifact repositories. It's just a kind of files. And once in the JFrog or in the JFrog Artifactory, what happens is again the sneak tool will be sneak is something vulnerability tool will be running it onto the top of Artifactory tool. I mean on the top of your artifacts in the JFrog or SonarQube. So and some of the unit tests. So these are some of the things will be running on the artifacts. And once it is successful or once it is done, those things will be pushed to ACR or ECRs. Okay, ACR or ECRs is something container registries, you know. So your Docker image will be stored there with the tag, and with that tag, you will be once you, I mean, from the Kubernetes, you will be able to push it, or I mean, from the Kubernetes, you will be able to pull that image and you will get it deployed, and it will get deployed and you will run the application, right? So this is how the end-to-end flow works. I mean, this is how the end-to-end, for example, if you go to the interviews, so if they ask, if you tell this is how in our environment works, that's fine. That's how it'll work out, right? Any doubts on this? So that is how the DevOps, I mean, the outer view, I can say. This is how the DevOps, one of the example I told, uh, this is how the DevOps complete structure will be there, you know, I mean, from the end to end CI/CD pipeline, right? So, yeah. And, yeah. So now coming to, yeah. So now, we'll discuss about what are the tools we'll just touch base on. For example, what are the tools we'll discuss in this course. So this is something first I told you, this is the Git and GitHub. So that is a tool which we are going to first touch base on, and the Linux is the environment. Uh, so Linux is something, it is the base, right? And operating system, I'm telling you, that is the Linux, that is EC2, Red Hat, and the package, and we are going to discuss about the shell scripting and the version control, Git and GitHub, and we will be using VS Code, right? And we will be using Docker. So Docker is something kind of, as I told, this is kind of package application with dependencies, and source code. Uh, yeah, so this is about introduction. Who is that? Mahinder. So this is just an introduction, Mahinder. So these are just touch base, kind of touch basing on all the uh, topics what I'm discussing on. But when I go into the deeper, go into the inside one of each topics, then I'll be able to share the PPTs or step by step. How do we, for example, how do we uh, install an application or deploy an application, or how do we configure the CI/CD? So these all things I'll be sharing it when I go into the deeper, go into the each topics wise. Okay. So as this is just an intro kind of thing, so I haven't come up with any PPTs or any note, I mean, any documentations, right? And coming to container registries, what we have is Docker Hub and ACR. ACR is something Docker Hub and storage, which store the container images, container registries are. And we have AWS ECR, and we use AWS, I mean, Azure ACR, Azure Container Registry, and AWS ECRs. Okay. And coming to CI/CD tools, what we use is Jenkins we use, and the latest one, GitLab CI/CD we might use. We can, based on the requests, or Azure DevOps pipelines we use, and AWS DevOps pipelines we use. And someone asked yesterday, I mean, we will be teaching AWS DevOps and Azure DevOps. So we are going to cover in this. And Artifactory, we are going to AWS Code Fact and Code Artifact and Azure Artifacts. And so I can give you, so I'll just share my screen. I can give you the tools here. I mean, I can write the tools so that you can refer it, right? Hope you're able to see. So operating system, we will OS Linux, and we will be doing with scripting, Bash and Python. So why I'm going to touch base on Bash and Python is it's very essential for us to now see. Everyone says that, yeah, we have copilots, we have Python. I mean, we have chat GPTs. Why still people are asking outside? I mean, the market, why they are expecting the scripting is, for example, you see, if you know coding, everyone, I mean, with the chat gpt, everyone will was able to write the code, or everyone is able to do whatever they want, right? Everyone, for example, you can write, the non-developers can write the code, and developers can write the code. So what is the difference between those two people? So those who know the coding, they can easily correlate, and they can easily modify according to your requirement. And what logic you want, you will grab that, and you will, it's a kind of, on top of that, you can use it as a wrapper, and you can get the benefit more out of it. So if, for example, if you don't know the coding, if you don't know the basics, what happens, whatever the chat gpt will give, you will just consume that, and you will just execute it, and you will, I mean, you will just execute it, and you will uh, get it solved. For example, you see, you're going to a destination, and you don't know the route. However, you book through Ola, I mean, you go through Ola, or you go through public transport. Every day you travel, but you don't know the route, right? One day, what happens? You have to go by alone, which you can't. I mean, after 1 year or 2 years, you have to go through. I mean, you have to go to your destination without using any public commute or anything. So you will be getting stuck, right? So it will be easy if you observe every day. For example, if you know the route, and if you take the transportation, and so you can explore so many ways, like shortcuts and all. Once you know the concept, or once you know the basics, so you can explore so many things, you can utilize into the core, the same chat gpt and all. So that's what my intention was. So get the basics of Bash and Python. Even if in the interviews itself, they will not ask you to write the code, something, I mean, they will ask you to write the code, but which are basics, and they will not they will not expect you to do the coding in the environment in the once you join, I mean, once you go into the join the industry. So they will not expect you to write full-fledged development or full-fledged coding. So getting the basics or getting to know the basics of scripting is very essential, and it will be helpful for you a lot in your career, right? And coming to version control, we will be using Git and GitHub, and we had GitLab and Bitbucket as well. And those are some of the tools. And I'll tell you what are the difference between GitHub and GitLab, Bitbucket. But we will be touch basing on more. I mean, we will be working. I mean, we will be working on mostly on Git and GitHub, and we will be using VS Code as an IDE. I'll tell you how to use the VS Code as well. So in the industry, most of the people use the VS Code to do the developments and to push the code or to clone the repository, whatever not, I mean, whatever. So we use uh, most of the people use the VS Code. And coming to containerization, yeah. So we have only one, that is Docker. And we have on top of the Docker, it's a kind of wrappers we have. For example, Azure ACRs, and we call it as an AWS ECR. So these all kind of container registries like Docker Hub. So for example, if you need to store your data somewhere, right, you need some kind of hub, right? So you take the gated communities. So all the houses, all the small flats consists of one hub, kind of. So like a gated community, or uh, so like an so all small restaurants, like we will be having all the small restaurants will be together, right? So that is kind of, it's a kind of hub, we can say, Docker Hub. And we call it as a container registries there. We have Docker Hub and AWS ECR and Azure ACRs and Azure ACR. And now coming to CI/CD tools, what we use is CI/CD tools. First is for build automation. We use Jenkins. And I'll tell you what is the difference between GitHub Actions, GitLab CI/CD, and we will discuss about Azure DevOps and Jenkins, Azure DevOps, and AWS DevOps. Okay. And we have Artifact, the repositories. It's like we use JFrog, which is the outside tool, I can say. And we will be using AWS Code Facts, AWS Code code artifactory, we can call it as, and we call it we'll do Azure artifacts. And for static code analysis, we use static code analysis as well. We use Sonar Cube, or which is the best one is Sonar Cube, and we'll use Sneak. We call it as Sneak, or yeah, Sneak. So I'll tell you, with the use of Sneak, you can become the DevSecOps. So how many of you heard about this DevSecOps? Yeah. So I just want you people to answer. Anyone heard about the DevSecOps here? Yeah, you can answer, yeah, whether it is no or yes. Any answers?
Yes, Manikant.
So what is the difference between DevOps and DevSecOps? What do you feel the difference was?
I don't know the difference and all, but I heard the term.
Terminology,
Yeah.
right? So the main difference was the security. The name itself, you can visualize like it's a kind of security. So what happens? They had came up with DevSecOps, kind of enabling this sneak tool. So it's kind of vulnerability scanning. So it does the vulnerability scanning of your code, and so it's just an enhancement of extra layer for DevOps. It's a kind of security. That's also we are going to discuss the DevSecOps, and yeah, so that's what the DevSecOps is. So mainly enabling with a simple sentence with enabling the security for development and operations, and the CI/CD pipeline we can say. So that's what the Sneak is, the main tool what we use here for the DevSecOps. And for secrets management, we use HashiCorp. I think most of the people might be heard about this HashiCorp Vault. HashiCorp is something. So it's a kind of third-party tool. I mean, it was developed by HashiCorp Vault is something. I mean, it's managed for. It's used for managing the secrets, and the best part using HashiCorp Vault is it can be integrated with the multiple technologies. For example, it can be integrated with the AWS, it can be integrated with the Terraform, it can be integrated with Azure. So multi-cloud platform, we can integrate this HashiCorp Vault. And the best thing is it encrypts the data, the sensitive data, and it can be decrypted. And we can use the API calls to encrypt or decrypt, and to call the secrets. And every secrets will be stored in a kind of key value pair. Key value pair in the sense it's something. So in the dictionary we can say it's a key value pairs, right? So that's how every secrets will be stored. We'll discuss more about that when we get into that. And yeah, those are the features, like we can do the encryption as a service, and we can do the auditing, secret management. See, these are all things we can do with secret management. HashiCorp. And right, and we use Argo CD as well. For example, now coming to deployment, deployment part, deployment automation, we can say. We use Argo CD, which is the latest one, which is the best one in the industry. We use Argo CD. And we use Jenkins as well to the deployments, automated deployments for the deployment orchestration. And we use configuration management. We use configuration management called Ansible. So Ansible, as you know, for example, we have hundreds of servers, and you want to manage those 100 fleets of servers. So how do you manage those hundreds of servers? For example, if you want to execute a simple command, uh, do the list of files, how many files were there on the servers. So how do you do that? Do you go to the individual servers and do you execute? No, right? So with the Ansible, what happens is, so you can execute multiple servers at a time, I mean, multiple commands at a time on multiple servers. So have you ever thought the difference between, I mean, orchestration and what do we, Terraform and Ansible? Anyone? Anyone can say the difference between Terraform and Ansible? What we use Terraform for and what we use for Ansible? And what is the difference? I mean, the difference between configuration management tool, we can say, or the orchestration tool. So what is the difference between those two? Any guesses? Anyone?
Sir, Terraform is like for main building of that one. And Ansible, we can maintain it on that one.
Okay. So
For
Terraform,
infrastructure purpose, we can use Terraform.
yeah.
And
So even we can use for Ansible as well, right? The
sir,
infrastructure
for
piece.
configuration, I am using Ansible. So
Okay,
if I want to create like server and those instance and all, I can use Terraform.
great. So it's for orchestration. So if you want to spin, for example, the whole environment at a time, so you use it Terraform. So for example, sorry. So what happens is, uh, for example, you had a server, you had a Kubernetes cluster, right? So usually what happens when previously in the data center, there are individual components. For example, there is a Linux, to build a Linux server, I'll tell you, to build a Linux server, you need the networking, you need the motherboard, you need the hard disks, I mean, you need the hard drives, and you need Ethernets. So how many of you heard about Ethernet bonding and all? It's long back. Now, I think there are very limited people who are doing this Ethernet bonding and all. And there are NICs which are required. And the networking, Ethernet bonding and all. And whatnot, you need lot of components. For example, if you want to install, you need BIOS and all, right? So once it got transformed, we got VMs, right? And from the VMs, what's happening in the VM virtual machines? So we are not with a just click of with a just one click, we are just installing it. Previously, we used to go to the what we used to do when I started initially. So I used to go to the we worked in data center, and we used to carry the CDs, the hard drives, and we used to carry the hard drives and we used to install it in the physical servers, and we used to boot the OS, and we used to install the individual components. We use that is called hardening of the servers. So we used to harden the server. We used to do hardening of the servers, and we used to apply the patches, and we used to install the applications. These are all things we used to do, right? When I mean initially when I was in my career. So after that, we got the VMs, virtual machines. Oracle virtual machines, and so with the virtual machines, what's happening? The main difference between, so can you tell me the different what is the difference between the virtual machine and the physical virtualization and the containerization, or you can say virtual machine, or virtual machine and physical machine. So can anyone tell me the basic difference between the virtual machine and physical machine? I'll tell you the containers as well. If anyone has
So
any
virtual
idea.
machine essence it's like a computer inside another computer. So each virtual machine is have its own OS, and physical
Okay.
machine is a simple machine that we use.
Okay. Still.
For virtual machine, we use the physical server, and on the top of the physical server, we install the hypervisor. And using that hypervisor, it spins the VM, and it takes the same OS.
Great. Super. So yeah, so that is what. So uh, operating system, as I told, first is physical machine, which is on bare metal server, that is on the hard OS. That is on the complete complete one physical server. For example, I'll tell you one of the servers what I had worked on. Inside, if you correlate with the AWS or Azure, so there are very huge Dell servers we have, and we had HP servers. So those all are in the part of the game. Dell servers, HP, and we have Oracle, very huge servers. If you see, I'll just show you. Have you seen anytime the data centers, how it looks like? I'll show you. Let me show you. So this is how the data center looks like, you know. So what we used to do is we used to go here, we used to take the LAN cable, we used to connect it, and we used to, I'll show you this one, how we used to connect. So there are some LAN cables, and yeah, so this is how we take the servers outside, these are the rack servers, we call it as. Okay. So these are some of the kind of Dell servers, and these are the hard disks. How, see, everywhere in the backend, uh, if you see Amazon, AWS or Azure in the backend. So these are what the data centers, and everything got installed. Everything is a VM, virtual machine. If you see, right, virtual machine with different configurations. Those are not the physical servers, right? So those are all the virtual machines, and they are installed on this hardware. If you see, these are kind of hard disks, right? So these are kind of hard disks for every service. They will remove this slot, this slot, this slot, and we can remove those slots. And so that is what. So, and we will connect directly, go to the we'll take the laptop, and we'll connect it directly, taking the LAN cable to the server. And see, this is how we connect. We have a stand, and we take this one of the server, and we connect it. You can visualize, right? So those are very big data centers. We have thousands of servers, and we used to connect it, and we used to daily troubleshoot, or we had consoles at that time, but still some of the problem, for example, the server went into hung state. What happens now? We had a console in the sense, we had an management complete console, where we can do the hard reboot, or we can do the soft reboot, and all we can do. For example, uh, even if we do the hard reboot is something pressing. For example, hard reboot is something, what do we call, So here we will be pressing the button complete. I mean, we will, for example, in your for your devices, if you press it, the power off button, and it will turn off and it will turn on, right? So that is what hard reboot. So soft reboot is something it will just, you will be doing it from the console. So that's what the soft reboot is. So we, even if you do the hard reboot or soft reboot, the server doesn't come up because of the hardware failure. So what we used to do, we used to go there and we used to get it connected, and we used to get connected to the servers, and we used to see what's wrong, and we used to go into the single user modes, and so these are all things we used to do, so in the data center. Yeah. Now, yeah, coming to the what is the difference between, so as you people told, so these are bare metal servers. Okay. So these consist of hardware and operating system. On top of that, for example, hardware is something CPU, RAM, and disk. And on top of that, we had an operating system that is Linux. And on top of that, we will be installing the applications. For example, you can install two applications, three applications, or four applications. The problem is one application is consuming more memory, so it will be getting affected the other applications. For example, one process is taking lot of consumption or lot of memory, one application. What happens? Remaining application, it will get affected in onto the remaining application. For example, you take a family, right? So if you are a joint family, right, and if someone has a joint family staying in a single home, and if they got 3 4 kids, and if they goes on increasing, and remaining people will suffer, right? And that's how. And if you people stay alone, I'm not saying you people should stay alone, but I'm just saying, if the family gets separated into each, they go into the separate flat, they can uh, you can see they can expand and they can enhance, they can do whatever they want, they can have the privacy and all. So that's what, there were no isolations in the bare metal server. One app, one application can affect another one. And for example, one application in the family, there are only two people. Okay. And the complete, I mean, it it's a kind of, they're idle, they're not using the resources, what are they, I mean, what they are having, right? They're simply wasting the resources. That is one thing. And it is difficult to manage scaling and scaling the environment. Scaling means what? Like, it's expanding the environments and all. We cannot do that, right? And it only works on your machine. Once you go out of that machine, whether it works or not, we doesn't know. For example, you install the application on the server, you install the application on one of these servers, and you want to, that server got affected, and you want to migrate this application to another application, to another server. So what do you have to do? You can't, I mean, you have to install all the dependencies, you need to do all the things what we have, I mean, you need to install all the applications, right? So that is what one of the biggest drawback. And no scalability on the environments, and very complex to manage, right? And for example, now coming to, so there are some use cases where you can use those one. For example, if you want high performance workloads, right, needing direct hardware access, like for example GPUs or databases which uses extensive memory or extensive CPU process memories and all. So then you can use these things. What do we call? Then you can use these physical machines, right? For the gaming and all GPUs, you can use the physical machines to the extensive, to use the extensive. Uh, Obviously, there is a difference between the performance between these and the VMs and the containers, right? And coming to the VM, so what is a VM? It's a kind of software-based emulation of a physical machine. So it's a kind of each VM has its own OS. So it's a kind of software, right? Software getting installed on top of the OS. It's a kind of, we had an hypervisor. Okay, so the layer will be like this. So you can see this, right? So virtual machine. So on top of the hardware device, there is a thing called hypervisor on top of the host, which will be installed on top of the hypervisor. There are multiple VMs, virtual machines. For example, on this virtual machine, you can install Linux. On this virtual machine, you can install uh, what do we call Windows. So you're using underlying, you're using, for example, 100 GB of the hardware. You take the memory, you take the storage, I can say. Okay, so you take the storage of 100 memory and you can distribute between these, how many VMs you create, you can distribute between them so that it will be, those will be used efficiently, and those are very light. I mean, not that light, but those are very light compared to hardware, right? So, and each VM, for example, this works independently and this works independently and this works independently, right? And so it supports multiple OS. So only thing is hypervisor is a software and installed on top of this, and we created different virtual machines, and it's easier to take the backup, and it's easier to take the snapshots and all. And obviously you can feel the difference, right? So difference between this and difference between whatever the physical machines, right? And the only limitations is, so these are bit heavy, and while starting or stopping, these interact with the hypervisor, and they are bit slow. And for microservices, we cannot use this because we cannot lift and shift that easily compared to uh, the Dockers, or compared to the containerizations, right? And so yeah, in the same apartment, this we can take the same example as apartment in the same building. So everyone has their own kitchen, bathroom, and walls, secured, but more uses more spaces, right? So that's what we can correlate with. And one of the use cases, hosting multiple environments on one server. That is how we can see in the backend, AWS or Azure, any cloud provider are using hypervisors or VMwares. So the underlying concept is same. Now coming to containerization. So I had a hard stop at 7:30, and yeah. So containerization is something kind of OS level, lightweight virtualization at the OS level itself. So I'll show you this. See, you can easily differentiate it. So on top of infrastructure, there is an operating system. On operating system, its operating system is nothing but host OS. And on top of this, this is a Docker engine. They're installing the Docker engine, right? So what happens is the container shares the same host OS kernel between, but isolate the applications and its dependencies. For example, what happens here is the same kernel will be used to all the VMs, and here the kernel will be shared between the OS, between the applications. So it is much faster. It's way faster compared to the hypervisor, and it's very easy to. It will be easier for you to access. Access in the sense easy to lift and shift. And as I told, first is hardware, and on top of that, host, and you can install the content. There are containers. For example, this is app and all these things. So these are boot. These get startup in very fraction of seconds, and these are perfect for CI/CD applications, and works everywhere across any environment, and these are used for scaling the things. And yeah, so that's what the containerization and virtualization and physical machines. And yeah, any doubts on these things? Right. So you can post your doubts. If you have any doubts, you can post your queries. We have a WhatsApp channel, right? So you can post there. And tomorrow we'll discuss the remaining tools what we have. And tomorrow we'll discuss those tools. And I have shared these tools in a chat. And I'll share you this notepad as well onto the chat. Yeah. Thanks, guys, everyone. Thanks for joining. And sorry, I have 7:30 hard stop. I mean, I had a meeting now. So yeah. If you have any doubts or any queries or any concerns, you just reach out to in the WhatsApp, or you can just reach out to us. And yeah, if you have any queries regarding today's class and all. Thanks, guys.
Thank you.
Thank you.